Morning, class. Welcome, great hosts, to yet our other mathematics session where we are looking at different aspects of your syllabus to do with your approach to the final exams. And we have done a few topics already, and I actually encourage you into this as you can follow our channel even on YouTube. We are offering Smart Caps lessons sponsored by Fibertech, as well as the Department of Education and other companies. I'd want to remind you that you can actually dive in and also be part of the assessments that will come along the way. And to join these assessments, you need to go to www.hellosmart.com, and then you'll be prompted to sign up as a guest and use the ID 598751. So if you use that ID and you add, then you are already in the assessment. You can actually interact and talk to us and give us your feedback on whatever assessment will be posted there for you. So this is a live broadcast which you can actually interact and talk to us, and we will see where the areas that you need help with. But if you are already on while listening to this, you can also pause the video here and there to practice and understand certain areas that you might have missed. Today we actually looking at the topic of polynomials, and we began to look at how you can factorize your normal expressions using different methods. Some of the methods that we talked about include, but not limited to, how that you can look out for a common factor and then you factorize a polynomial. You can also group or pair the expression and then you factorize. You can also, in your factorization, be able to recognize factors that would give you in the end. So you kind of speculate and also use trial and error and your own experience with multiplication to know that, for example, if you have 12, you'd know that the factors might be 3 and 4, or 6 and 2, or 12 and 1. So you look and you check what would fit for your recipe. And then you also realize that we did mention that in your factorization, you can also use the quadratic expression or formula. And this quadratic formula, you simply substitute your coefficients of the expression and you get your root, the x value that would give you your answer, which you can easily also use to factorize. We also mentioned, along with solving expressions, that you can also use the completing the square, which is also another way to factorize, and it's good in that you can also use it in Euclidean geometry as well as in functions, where you might want to talk about the turning point and all that. So it comes in such areas where you are applying in different topics. Okay. So we left it at a point where we had shown you about the synthetic method that you can use to actually also factorize by division, and it's a method of being a bit on the short path of a long division. So long division can be used to factorize as well, and the factor is not a real which can divide there, you see that it will always have a remainder. But if the remainder is 0, it means that the factor which is dividing is actually a correct factor of the expression. But we started to become very clever, and we want to look at other means that might make life easy on. And one of the ways would be to find a way that would seamlessly give us a remainder or a factor or factors without so much sweat as the long division and all these formulas. So we started to investigate into the remainder theorem as here shown on the screen. And you have started to realize that it's one of the fascinating that can give you magnificent results. And in that regard, to remind you what we started to talk about the remainder is that if you are dealing with any polynomial and you want to divide it by a factor such as x minus c, c being a number, isn't it? So you see that if you get to find the remainder, you can simply say f of c. So that sounds very smart. I will show you, and it helps us in solving a lot of problems. Even if the factor that is divided is in the form like ax minus, so this might be, for example, 2x minus 3, then you simply say f of c over a. So how do you know this argument of f that we are putting in bracket? You simply know it by making or finding the root of, so you make the expression equals to 0, then you find your x. That particular x is the one that we are inputting as f of x, in this case, the root of, and then we get our remainder or the factor to prove that it's a factor. Okay, so with that, we mentioned how you can use the remainder theorem if you have an expression. So, for example, in this case, we say that you simply need to say x equals to 3 if you're looking for the root of x from 5.1, and then you look for x of 3. So you will get your remainder here. The same way on number B, you say x equals to minus 2, then you look for x, f of x, which is f of minus 2. That will give you a remainder. On the last, you simply say x equals to 1 over 2, because we have to make x the subject, and then f of half will give you your remainder. So let's check what that would give us in terms of using the very same approach. So f of 3 is giving us that we are simply substituting it in the expression, and it gives us 4. So 4 is our remainder. The second expression, f of minus 2, is giving us 9. And then the last one, f of half, is giving us a quarter. So in just one step, we get our result, which is the remainder. So the remainders are the ones being shown here. Okay. So that's how the remainder theorem works in a very smart, quick way. So to remind you of the formula, we can mention that the remainder theorem states that so f of x is a factor of f of x, then the remainder is 0. So that might kind of be fine, but we haven't covered that at least. If f of x is divided by x minus c, the remainder is fc. This is f of x. F of x is divided by x minus c, the remainder is 0. Then x minus c is a factor of x, f of x. So this is something we're gonna prove to be correct, but it's a different theorem. It's a factor theorem. And then if f of x is divided by x minus c, the remainder is f of minus c. So this is not correct. The first one we said if x minus c is a factor of f of x, the remainder is 0. So the remainder of what? When we divide. So this is not giving us enough information because we are talking of the remainder theorem, and the most correct answer, as we just saw, would be your B. We showed last time how that works, and looking at another situation, find the remainder if g of x is divided by x plus 2. So you can quickly check that one, and you see that it's a matter of saying g of minus 2, because that's what you can get from there. And then you substitute that minus 2 in the expression, and that would give you 4 plus 6 plus 3, which here is 3. So your answer will be A in this case. Okay. So another situation now could be, what is the remainder if P of x is divided by x equal x minus, so x is equals to 4 here. So let's substitute it in my expression of P. So we have P of 4, then we have 4 cubed minus 4 squared plus minus 9. So this should be quite a big number, because this is like a 64, this is a 16, this is a 4 minus 9. So you can see that you almost have, so whatever, you can use your calculator here to make life easier for yourself. And so you almost have like 70, if you are checking, yes. So you almost have a big number, which you need to find out what it can give you. And so it can be 70 something or so, or then you subtract. So in the end, D is our answer. As we said, that would be a big. So we did this part and we got our answer as D. So you can simply use the same expression to find your way around. Okay, so this first part, your 16 times 4, yes, would be your 64, and then you work out the rest. So you have a subtraction section here. We have to be careful to put this up so that you get this 43. Okay. So that is how you can factorize or actually get the remainder of this expression. Okay, but we did all this in retro. We can say that we are able to solve, example, this particular question. So those who are using gadgets, you can simply connect to this exercise, which is your assessment. So you can actually join in, and as we said, you can do that easily by going to hellosmart.com and you sign up as a guest using the ID number here shown again on the screen is 5941. You're gonna be prompted to it, and you show us how smart you are. So it will be a great journey to see how far you can go. Yes, so here is your chance to show off what you can do with number 16. So start to look at it. So there you go. You must be able to connect to the assessment running on Hello Smart, and you will be able to do or to check these particular exercises. Okay, I would want to us to do this one together as we go, and you are getting ready to do so much more from here. So here you can see that you can simply get your x equals to half by making x the subject equal to 0 there, which would give you x equals to half. So already you could almost, if you didn't have time in it, you'd simply go for this, because at least it is f of the x that you want. So we haven't worked it out, but that's the only one with the correct f of x. But let's find out if it's really 0 that we'll get. So f of half would be 2 half squared minus half, which is going to give us 2 over 4 in the, well, that will give us a quarter minus half. So this is like half minus half, which is 0. So yes, our solution comes out to be C, as you can see, which is correctly the f of half, which is equals to 0. Let's check yet another situation. When h of x is equals to x cubed minus nx squared plus 5x plus 1, when that one is divided by x minus 2, the remainder is 15. Use the remainder theorem to find the value of n. So I'm sure that you can use the remainder theorem to substitute things, and then your only unknown might be n, and you find it. So let's try to reload these guys who are on the gadgets. Okay, so let's see how you can actually be doing this. If you're using your handbook, you can simply be jotting down on your piece of paper and check what n value you get. So find out what solution you get from this question that is posed before you. Okay, let's check it together to save our time slightly. So there, I'm sure that there is got x equals will be the value of x you're going to use. And from there, we're going to go into our h of 2, which is our expression, up and then say 2 cubed minus n2 squared plus 5 into 2 plus 1. So be careful to write everything correctly. So you get 8 from a calculator as 4n plus 10 plus 1. And looking at the like terms here, you'd get sort of like your all the numbers are actually adding. So you have like 19 minus 4n. But what are we told that this would give? Remember this would be a remainder. So the remainder is already given as 50. So we are told that the remainder is 15. So with that, we simply going to find our n. So to do that, it's a matter of maybe bring your n side and then 19 minus 15. So whichever method you find easy for you. 19 minus 15 is simply 4, and you have 4n, so n equals to 1. So that would solve the case, and that is C. So the case is solved, and you can actually applaud yourself if you got to this expected result of C, which is n equals to 1. How about we check This is one of our last examples on the remainder theorem. So I want to give you again just a couple seconds or two to try and find out the remainder of that expression if divided by x plus 1. So do your best to check. Okay, let's delve into it yet again. I'm sure you got x minus 1 there, and then that means we are sort of concentrating on these two, isn't it? Because that's the ones with the expression where x minus 1 is used. Then from there, we're going to go into p minus 1, which would give us minus 1 plus. So we are looking at this expression at minus 2 cubed. So we simply substituted where there is x with minus 1. So the bracket actually contains minus 3 cubed, which is minus 27. So your answer is B in this case. So B is our answer. Okay. Then we are now going to be looking at another theorem, which is called the factor theorem. So the factor theorem actually states that if f of x is f of c is equals to 0, then x minus c is a factor of the polynomial f of x. Or if you like, the converse, which means the inverse of this mathematical statement. So the converse is that if x minus c is a factor of the polynomial f of x, then the remainder f of c is 0. So this is almost the same thing we're dealing with in the remainder theorem, except that now our remainder will be 0. So if our remainder is 0, that means that the factor that was dividing is actually a factor, and that will be your factor theorem. So you use the factor theorem and the remainder theorem the same way, same time, because they will simply tell you whether you have a remainder or not. So here is an example. Use the factor theorem to prove whether the x plus 2 is a factor of g of x of all that. So we still do what we were doing before, x equals to minus 2, and then we substitute it wherever there is x with that minus 2. If our answer is 0, then the factor is a factor of g of x. So that's what you have in the worked solution here. You have g of minus 2 giving you 0. So that being the result, it means that f of x plus 2 is a factor of g of x. So as long as your remainder is 0, that means what you are dividing with is a factor. So it's part of the expression. So another situation could be like this: factorize completely. So you do a lot of inspection and trial and error on this, because you might sort of try to guess what are some of the factors if you are not given, especially you are factorizing, like in this case. So you might guess that maybe if I put 1, it might give me 0 for the whole expression. And then you check. So that would mean if it's giving you 0 for p of x, then you have one of the factors. So one of the factors would then be x minus 1. We haven't tested this, but that's how you sort of do your trial and error. You test that x equals to 1 in the expression. If you get 0, then x minus 1 is a factor. So it goes something like this. Find the first factor by trial and error, as you've mentioned. And then in that case, if you guess that x can be 1, then p of 1 would give you that, and it's giving us 0. Quite likely, and that would mean that x minus 1 is a factor. I must say that in your guess, it's not about luck or anything. It's also about making what we call an educated guess. So by looking at an expression such as this, you must begin to imagine that what number would actually make this whole thing to give you 0. So you can sort of run a few numbers in your head that might give you 0 here. As you see that you could have tried x equals to minus 1, would also give you 0. So in the end, because you got one of the factors, you actually write that factor and then is times a product with the quadratic expression. How do you get the quadratic expression? You can use your long division, your synthetic method. You can also use sort of an inspection method to actually work out what this particular quadratic expression would be. And I think if you are not sure of your multiplication tables and your signs, negative and minus and positive, rather you would actually resort to either your synthetic method or also your long division. So that would help, and you can easily now factorize the quadratic expression. So what would you say then? According to the factor theorem, if f of z equals to 0, then x plus z is a factor of f of x. So there are different solutions being offered there. So you want you to choose which one is correct between A, B, C, and D. So try to consider that from the factor theorem. Okay. I think if you remember from our vector theorem, if f of z is equals to 0, then x minus z is a factor of f of x, would be more correct. We cannot take the first one because this must make this one to be negative, not positive. And we don't deal with this inequality. So that's why we discounted or discarded number A, B, and D and left with C as the correct solution. How about that? If G to the half equals to 0, identify the factor of G of X. Okay, so you should think in reverse or in converse. If you are experienced already with this expression, to how would you get half out of an expression with X? Is that expression A, B, C, or D? By simply equating to 0, you should be able to get your half and check. Okay, so hardly time that you can be done with this already. So if we try to use A, you will see that here we are equating everything to 0, everything to 0. So here X would be equals to half, quite correctly. On the second expression, X equals to minus half, which is not. And on the third, X equals, on the fourth, X equals to minus 2. So that is how things would go in this case. So our answer, of course, would be that that would be our solution. Okay. Find one of the factors of g of x. So if it's a multiple choice like this, you can actually use that this provided suggested answers as your tools to use as possible factor. So if there was no options given here, you might have to look into the expression and inspect it to come up with some factor. Okay, so let's try to think of this in terms of try to use your A, try to use your B, try to use your C, try to use your D. As long as you get your solution being 0, then it is a factor of that expression. So try to employ this in the expression. You might get a splendid correct answer, which will satisfy the whole question. And I'm sure that you have begun to look at this as expected. I would try to to actually consider that if x equals to -1, what would happen? So I'll put g of -1 and then get -1 cubed, -2, -1, -9, -1 plus 18, which here would give you -1 for the first part. You can easily use your calculator to avoid mistakes, and then +9 plus 18. So our 9 is positive, yes, because of the minus, and we have 18. So this doesn't give us 0, so it's not a possible factor. We have to try other ones. So by inspection, I can see that 6 would sound to be too big for some of the expressions there. And maybe you can try -half on, but I would want to start by trying D, because you don't have to follow a sequence here. We're looking for the one that will satisfy this. So you must make an educated guess to say, since my first one, which was x plus 1, didn't work, maybe I can try now 2. So it's always also within that range is a good guess to try your 1 or -1, your 2, -2, 3, sometimes -3 to get your first factor. Yes, expressions might be different, but it's worth trying with for a start. So I want to try with g of 2. So I'm taking it from here. So it's 2 cubed -2, 2 squared -9, 2 plus 18. So the first part gives us 8, and then there is 8. So this we have already cancelled each other. Let's see what we have on the other side. -18 plus 18. These two cancelled each. So your answer is 0, which we wanted. So that means that is a factor of your expression. So D, as I actually looked at it and speculated, D is correctly the answer. So you do similar things with various expressions, as you can see. And because of our time, you also have a situation where you have that. So if you check in this case, the expression is the same, I think, with this one, with the previous, except that now we have a minus on there was a minus here. So this time there's a plus. So it's a different thing. You might want to be aware of that. So with this expression, you want to find which one is not F. So what you simply do, you equate everything to 0, everything to 0, everything to 0, everything to 0, and you actually put them into your expression. Whatever doesn't give you 0 will be your answer, because this time we are looking for not a factor. So I want you to write down this expression, this question, or to pause if you're on you and find which one between A, B, C, or will be your solution. The other question I wanted you to look at as your homework is also this: factorize completely. So you want to factorize this using factors. You can first make your first educated guess at which one would be your first factor that would give you 0. And then if you have one of the factors, it's easier to factorize the quadratic expression that results. So look at this as a homework, and that would actually do the trick in our topic of polynomials. And we want you to re-emphasize and find out how this is a smooth way to actually solve factors. So that will be your play if you involve yourself into this and find the easier methods we have shown you to find factors. I would want to thank you for being with us today in our assessments, as well as in the session of our Smart Caps lessons that are proudly sponsored by VT Africa Holdings, the Basic Education Department, Fibotech, Stratech, and other well-wishers. With that, I would want to thank you and say have a great day. We meet tomorrow for our session in maths, and we'll be actually in certain aspects and also going forward with the next aspect. So you have the chance to also join in on YouTube on our channel, and you get feedback, all the feeds that are coming in of different subjects, which also include physical, accounting, geography, and as well as coding. With that, I must say have a great day. I'm Rollins.